In this module, we will cover the strategy pattern, also known as the policy pattern. It's one of the most commonly used behavioral patterns. The idea behind it is that it will let an algorithm, the strategy, used by clients to achieve something vary independently from the clients that use it. I'm Kevin and I'll guide you through this module. We'll start by describing the pattern using a real-life example, exporting an order to a certain format. After that, we will map that to a structural example and we will implement it in a demo. We will also implement an alternative approach to the original pattern template. We'll continue with learning about use cases for this pattern and pattern consequences. And as usual, we will end the module by looking into related patterns. Let's dive in with describing the strategy pattern. The strategy pattern is a behavioral pattern from the Gang of 4 library of design patterns, and probably one of the most often used behavioral patterns in existence. Its intent is to define a family of algorithms, encapsulate each one, and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. Put in other words, you define a family of algorithms, put each one in a separate class, and make them interchangeable. That definition might sound a bit weird at first, but just think about technically implementing an interface and it already becomes a lot clearer. Imagine the following use case. You're working on a part of a system that manages orders. At a certain moment, a business requirement comes in. The order needs to be exportable as a CSV file. You can solve that by adding an export method on the order that creates this CSV file. So far, so good. A bit later, another requirement comes along. You need to support exporting to JSON as well. This is still manageable. You can accept a parameter in the export method, export format, and depending on the parameter value, execute another piece of code. Yet it appears that 2 formats are still not good enough. A few weeks later, XML export must be supported. And now it's starting to become more difficult to manage. You could continue on the same route, adding an additional format type and extending the conditional statement in the export method. But you're already noticing some disadvantages to this approach. The order class is becoming more complex with all this export logic contained in it. Moreover, when you want to change export logic or add new ways to export, you always have to change the order class. This also definitely means that the order class is starting to have too much responsibilities. And you can partially solve that by adhering to the single responsibility principle. You can put the different types of export functionalities in classes of their own. CSV export service, JSON export service, XML export service, and so on. And store instances of those on the order class. In the export method, the correct instance is then used, depending on the inputted export format parameter. Yet that also means that the order class is now responsible for the lifetime management of the different export services. And moreover, you've tightly coupled the order class to these implementations. That still makes it hard to add export functionality for new formats. Enter the strategy pattern, which solves these issues. The first thing we'll do is declare an interface, iExportService. This declares one method, export, which accepts the thing to export, the order in our case. Our 3 or potentially more export services now become implementations of this interface. CSV export service, JSON export service, and XML export service. In the export method implementation, the concrete export is handled. The order class then has a property of iExportService, which is set to one of the concrete implementations. Whenever export is called on order, the currently set iExportService implementation is used to handle the export. This means that the order object isn't responsible for selecting an appropriate algorithm, in other words, an interface implementation, for the job. It's the client that passes this implementation to the order class. The order class itself doesn't need to know about this. All it knows about is the interface and not the implementation. We've thus achieved loose coupling, making the order independent of the implementation. And that makes it easier to add new implementations or modify existing ones. There's no need anymore to change the order class to do so. Let's map this to the pattern structure. Let's start with our iExport service. That, in pattern lingo, is named a strategy. Such a strategy declares an interface common to all supported algorithms. The context, which is our order class, we'll get there soon enough, uses this interface to execute a concrete algorithm. And that brings us to the concrete strategy. These are implementations of the strategy interface. In other words, they implement the algorithm using the strategy interface. This maps to our different service implementations. The last part of the story is the context, which maps to our order class. This is configured with a concrete strategy object and maintains a reference to a strategy object. That's what the arrow from context to strategy means. It often also contains a way for the strategy to access its data. In our example, that was the export method. That method would require the data that needs to be written to the file, for example, by passing through the full object that needs to be exported, the order in our example. And with that, we know about the pattern structure. Let's implement our real-life scenario next, and let's also implement a variation of it in the upcoming demo. Let's start with creating the strategy. That's our iExport service interface. We're using an interface here, but the pattern can also be implemented with an abstract base class in case you want to provide some out-of-the-box implementation of parts of its functionality. I defined one method on it, export, which accepts an order object, as it needs its data to be able to export it. This is just one way of providing an interface to the order data. Another way could be to accept just the property values that need to be exported. In our case, we're mimicking that we need access to all properties of the order object. We haven't got that order class yet, but we'll get to that. In our real-life example, we had 3 different formats to export to. So let's create implementations of the strategy for those. These are concrete strategies. So we've got one concrete strategy, JSON export service, which implements the iExport service interface. That means we need to implement the export method, which we do. Our second concrete strategy is the XML export service, which follows likewise principles as the JSON export service. And the last one is our CSV export service, which also follows the same principles. We implement one method on it, export. And maybe now it's time to get that order to resolve. So let's add an order class. That order class that maps to the context component of our pattern structure. It's a pretty straightforward class. We add a few common order-related fields and a constructor. The important part is what's coming now. We need to add one more property to our order class. And this one is of type iExport service, our strategy. It will be set from outside of our order class, so it is nullable. And then we add an export method on the order class. As we learn on the slides, it's in this export method that we use the strategy to export the order. Important to know is that the order class doesn't know about the concrete implementation of the strategy that's going to be used. All it knows is that something of type iExport service will be used to export itself. And with that, we've created all the different moving parts of our pattern. Let's add a bit of code to test this. So let's new up an order. And let's try exporting it. It's up to the client to provide the concrete implementation of the strategy, and we do that by setting the export service property on our order. We set it to an instance of CSV export service and we try exporting. Afterwards, we set the export service to a new instance of JSON export service and we try exporting again. Let me add a read key statement here and let's give this a try. And there we go. This works as expected. Our different strategy implementations made sure that the correct export service was used. What would we now have to do to add a new export service? Well, the nice thing is that we no longer need to make changes to the order class as it's not tightly coupled to an implementation of iExport service. Note that this implementation does mean that export can be called without an export service being set. To avoid that, we could provide a default value. For example, in the order constructor, we can set the export service to a new instance of CSV export service, stating that that will be our default value. Another approach would be to not allow the order to be constructed without providing an iExport service implementing object. When we implement it like this, it's still the caller that provides the default and not the order class itself. That being said, these days, dependencies like this are often injected via an IOC container, which tend to have their own null checks in place. But even then, it still remains a good practice to check for null reference issues. Let's get rid of this to ensure that our demo code still builds. And let's continue with looking into a small variation of this in the next demo. In this demo, we will look into a variation of the pattern template, which is still a valid strategy pattern implementation. What we can do is have the export method accept an iExport service object instead of storing it on the order class. We add a null check, and instead of using the export service property on the order class, we use the pass-through instance. That means we can also get rid of this property. There we go. This is a variation of the template, and it thus looks a little bit different from the structural design pattern. But in essence, we are still leveraging the strategy pattern here. The intent is still the same. Let's change our test code to accommodate for this adjustment. So we don't have an export service property to set anymore. We simply pass through an instance to the export method. And let's give this a try. And there we go. This still works as expected. This was a very small change, but it is one that you'll often encounter in today's code bases. In essence, all these methods that accept an interface instead of an implementation to achieve a task are thus implementations of the strategy pattern. And that is why this pattern is so commonly used. Let's look into a few of those use cases next. You can use this pattern when many related classes differ only in their behavior, so not in their interface. Strategies provide a way to configure a class with one of many behaviors, as we've seen with our 3 different export service implementations. You can also use it when you need different variants of an algorithm, which you want to be able to switch at runtime. An export algorithm to 3 different formats, for example, again, as we've just seen. Another good use case is when your algorithm uses data, code, or dependencies that the clients shouldn't know about. Imagine that exporting to, say, a proprietary format needs some additional configuration or properties. The clients don't need to know about this or be allowed to change it. When they're working on an interface, they don't know about these. They only know about the export method existing. Lastly, use it when a class defines many different behaviors which appear as a bunch of conditional statements in its methods. In other words, when you're dealing with large if or switch statements. And that's the example we started with. In the export format method, we had to look at the export format parameter to decide on CSV, JSON, XML, and so on. You can use the strategy pattern to avoid this. Let's have a look at the pattern consequences.